So now that we've talked about Java terminal operations at the high level, let's kind of focus in on two of them, forEach and forEachOrdered. And these are run-to-completion terminal operations that return no value and only have side effects. If you recall our discussion about side effects, we talked about how we try to avoid side effects in general with Java streams and behaviors. This is one case where you have to have a side effect. So this is the exception that proves the rule, if you will. And we'll see this in the context of our little Hamlet example again. So we're also going to talk about some of the traps and pitfalls with using these operations because, as always, it's not all rainbows and unicorns. There are some problems with this, which, of course, are settled and addressed with other terminal operations later. So forEach and forEachOrdered are terminal operations that don't return any value. They have a side effect instead. And we're going to show some examples. If you want to run these examples, which you probably should if you really want to see how this works, take a look at the EX12 project in my Java 8 folder in my live lessons GitHub repository. As usual, you click on the slides and it'll take you to those links. What we do is we create a stream that consists of the characters from the play Hamlet. We've looked at this a million times, so I won't go over this. And then we're going to perform the designated action. And the designated action, as you can see, is presented as a method reference. And it's the method reference for the println method in Java. And you all know, hopefully by this point, that println has the side effect of printing whatever it gets as input, it's one parameter, to the standard output. So pretty straightforward. Let's compare forEach, which is super simple, with forEachOrdered and understand why there are two of them and how they compare and contrast. So forEachOrdered is needed if you want to present the results in so-called encounter order. That's important for your program, to present the results in the order in which they're encountered. First of all, what the heck is encounter order? So encounter order basically just means the order in which a stream encounters the data. Encounter order really has nothing whatsoever to do with whether or not the stream is sorted or not sorted. It has to do with the order in which things were encountered. So here we see Horatio occurs before Laertes, which occurs before Hamlet, which occurs before Gertrude or Claudius or Ophelia or whatnot. That's the order in which things were encountered. forEach does not preserve encounter order under some circumstances, whereas forEachOrdered does. Now, where does this matter? Well, it turns out it only matters, really, for parallel streams. For non-parallel streams, the forEach method will almost certainly give you the results in encounter order. But for parallel streams, where the intermediate operations can run in different scheduling orders, non-deterministically determined by the Java fork join pool and the underlying hardware and multi-cores and blah, 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 that might mix things up and they might run in different orders. So if you use forEach, you can get things in different orders just because of the way things schedule in the parallel stream. But if you use forEachOrdered, then it'll do things in encounter order. It'll make sure that the results come back in the order they were encountered. Does it really matter? Not a whole lot, but I want you to be aware of it. Here are some traps and pitfalls with using forEach and forEachOrdered. So what we're doing here, just to show this, is we're showing the example of side effects. We create ourselves a list of strings, which is a local variable called results, which is an array list. And then you can see here we pass results : add, which is the add method reference that will stick something into that list, to the forEach method. And that has the side effect of storing the results into the results list. OK, so far so good, sort of. Two problems. First, the programmer has to remember to actually initialize this. If you leave this out, if you say list string results, semicolon, then hopefully your Java IDE will yell at you and say you may be accessing an uninitialized variable, which would be good. But if it doesn't do that, then you've got a problem and you're going to get some kind of weird null pointer exception and chaos and insanity will ensue. Secondly, and perhaps more importantly to understand from a semantic point of view, if you happen to slide in the parallel intermediate operation here saying I want this stream to be a parallel stream, now you've got some nasty race conditions because a list of strings is not thread safe. So as a result, multiple threads will be adding into this list, and you'll get them stomping all over each other, and once again, you'll have chaos and insanity. Now, there's several ways to solve this. One sort of workaround for this problem, we would call this a kludge or a hack, would be to replace the use of a list of strings with a concurrent linked queue of strings. And that's because concurrent linked queue is a thread-safe data structure. So if multiple threads try to insert or find or remove things from the queue, the concurrent linked queue, everything is protected properly with the way that thread safety works. It has a lock, and the lock makes sure that you don't stomp on the data if you're reading and writing to it concurrently. However, this is still kind of ugly, and it's inefficient, maybe, depending on various factors. And it's error-prone because you have to remember to do concurrent linked queue and blah, blah, blah. You are probably, almost certainly, much better off if you find yourself with something like this and you find yourself needing to use a parallel stream, to simply replace the use of forEach or forEachOrdered with collect or toList or collect toList, as we see here. And that will allow the allocation to be done automatically. You don't have to remember to initialize the results variable. The concurrent processing is all handled seamlessly. You don't have to worry about race conditions, and it's way cleaner and more concise. So as a good rule of thumb, try to use the collect family of terminal operations for things like this rather than using the forEach with some kind of side effect to a thread-safe collection. So that's the end of the discussion of forEach and forEachOrdered.